Okay, so this is 2014, not 2004, 2014, number 5. Okay, so we have this chart, and it says that twice differentiable functions, so if they're differentiable, we have to keep in mind that they're also continuous. Find the x-coordinate of each relative minimum on f on the interval -2 to 3 and justify your answer. So, what I did was I know that a min has to go from negative to positive in f prime, right? So I look to see where it does that, and I see that it says that f prime, I go from negative to negative, so that doesn't help me. But then at 1, at x equals 1, I see that f prime goes from negative to positive, so that is a min. And that's it. You can embellish that a little bit, but that's basically the end game. Okay, so part B might be the hardest part of this question. Explain why there must be a value c for -1 is less than c is less than 1, such that f double prime of c is 0. So in your head, what you have to think about is picture f prime like being a function, and then f double prime is its derivative. So I can consider f prime. What does it mean for f prime, for if you have a function for its derivative to be 0? Well, it means that somewhere the slope of the tangent line has to be 0, right? We know by the mean value theorem that if we can find a place where the secant line is 0, then there has to be a place where the tangent line is 0. So basically you kind of have to go on faith that if I do f that this will give you 0, which it does. So, because this is saying this is average slope, right? So, since by the mean value theorem, since f is continuously differentiable, then there is a c on -1 to c. -1 is less than c is less than 1, where f double prime of c equals 0. So whenever you're trying to prove that the second derivative is 0, take the average, or find the secant line, find the slope of the secant line between the two endpoints, okay? That's the rule of, I would say that's a good rule of thumb here if you're really looking for, like, how do I know? Just if you get a question like this, take the slope of the secant line and pray that it'll be what you want it to be. So that's part B. Part C, they tell you h of x is ln of f of x. And they want you to find the derivative. So h prime of x, now I have to use the chain rule here. The derivative of the outside is 1 over f of x times the derivative of the inside is f prime of x. So h prime of 3 is f prime of 3 over f of 3, which for us is 1/2 divided by 7, which is 1 over 14. Part D, they just want you to do hopefully what you've noticed is that this is the chain rule. That is the chain rule. So if you're taking the derivative, the integral, because otherwise, like, you'd say to yourself, how do I take the integral of that? But that is the chain rule. or they say here in the scoring guidelines, the fundamental theorem of calculus. So what I know is that if this is the chain rule for f of g of x, which means that this is just f of g of x from -2 to 3. That's the integral of this. Because if I were to take the derivative of this, I would get this. Okay? So then this is just f of g of 3 minus f of g of -2, which ends up being 2 minus 8, which is -6. And that is question 5.